Hello, my dear students. I am Dr. Rashid Hashmi and you are watching Dr. Digital College. Yesterday, a student from India doing Edexcel International A-Levels Chemistry asked me one question. He is a very brilliant student and he was almost done with the whole of question. The question is related with the enthalpy change. Hess's law is applied in it. There was only one point the student was stuck in. I'm going to explain that little point. It's a very good question and you will really enjoy. Okay, let's have this. So the question is that when lithium reacts with water, it forms lithium hydroxide. We know that group 1 atoms, group 1 metal elements, they react with water quickly. Lithium, sodium, potassium, rubidium, cesium, they are reacting with water. Okay, and lithium hydroxide is formed, and that lithium hydroxide is quickly changed into lithium ions plus hydroxyl ions. That will be aqueous, this will be aqueous, and along with it hydrogen gas is produced. The question is, what is the enthalpy change of this reaction? Delta H theta of this reaction, what is it? Now, some of the values are given. Means one value is given like this, that when lithium hydroxide, it is dissolved in water, it forms the ions of lithium, positive plus hydroxyl. Both are aqueous. This is aqueous, this is aqueous. These aqueous are formed. And for this, delta H theta of the solution is minus 21 kilojoule per mole. Mean when it is dissolved in water, ions, lithium ion and hydroxyl ions are formed, and this is an exothermic reaction. 21 kilojoule per mole energy is given out. Now the other values given are, there is given delta H theta of the formation of LiOH solid. This is given to us. Delta H theta of the formation of water in liquid form, this is given to us, and delta H theta of the formation of lithium solid, it is given to us. Okay, this thing should be very clear to you that when lithium is being formed, lithium is the natural thing. For anything natural, the enthalpy change should be 0. So they have given us 0 enthalpy change for the formation of lithium. For the formation of lithium hydroxide, the enthalpy change is minus 485 kilojoule per mole. And for the formation of water, it is minus 286 kilojoule per mole exothermic. This is minus, the enthalpy change is minus. So these reactions are exothermic. Now we have to calculate this one, that when lithium will react with water, what will be the enthalpy change? So Hess's law will be applied here. You know that it's so simple that we are making here reactants, products and elements. From the elements you can make products, you can make reactants. Okay, so these products can be formed from the reactants, these products can be formed from the element. So Hess say that we can go through this route or we can directly go through this route. So if this is here A, this is B and this is C, it means A plus B will be equal to C. The enthalpy change of this process and this process, one route, is equal to the enthalpy change of the other route. This is Hess's law. Okay, I hope this is very much clear to you all. Now let's see how to make it. In this case, we have the reactants, water and lithium, and we have the products, aqueous lithium ions and aqueous hydroxyl ion. Now, if we write here the elements, lithium, hydrogen and oxygen in their natural form, these are, this is here lithium plus hydrogen plus oxygen. These three things are there. Now they can make water, okay, but directly this lithium plus hydrogen plus oxygen, they will not form lithium ions and hydroxyl ions. So first of all, lithium hydroxide will be formed, and then this will be reacting with water, or it will be dissolved in water to make the aqueous ions of lithium and hydroxyl. Okay, so in this case, it will be a double step. Now see how it will be the double steps. In single step, we cannot write it like this. Okay, so we were making this enthalpy cycle, and this enthalpy cycle will be like this, that if I will write here lithium plus hydrogen plus oxygen, we can make water, okay, and then to make this, first of all, we will make lithium hydroxide, and then from lithium hydroxide, we will make these two, lithium ion and hydroxyl ion. So it will be two step. But you know that this information is given that lithium hydroxide is dissolved in water to form lithium ions plus hydroxyl ions, and delta H theta of the solution is minus 21 kilojoule per mole. Okay. So should we include this water or not? This was the actual question of that student. So we have been given with delta H theta of the formation of lithium hydroxide. But lithium hydroxide itself is not making lithium ions and hydroxyl ions. Rather, it is dissolved in water, and then lithium ions and hydroxyl ions are formed. So should I write here water or not? This was the actual question of the student. Okay, now, what you guys think about it? Should we use it? Because we are also given the delta H theta of the formation of water. That is minus 286 kilojoule. This is minus 485 kilojoule. So should I include minus 286 once again over here? No. You just think. You can pause the video over here and you can think about it, that why shouldn't we include minus 286 over here? The answer is that these are the enthalpy changes when some bond is broken down or some bond is formed. Here the bond of water between hydrogen and oxygen is not being broken down. This is here lithium hydroxide, which is changed into lithium plus OH, and with it water is attached just like this. Mean the bond of hydrogen and oxygen is not being broken down. So why should the enthalpy of water be included over here? You know that enthalpy change of the solution is very small value for most of the salts. Why? Because the bond of salt is only broken down. The bond of water is not broken down. So is here that with lithium, water will be attached. Hydrogen and oxygen, bond of the water will remain intact. So this lithium is dissolved in water, this hydroxyl ion is dissolved in water, and this enthalpy change is just for the breakdown of the bond of LiOH, lithium hydroxide. So I have not to include water over here. Rather, I can say that this is over here aqueous. Mean I can write this water on the top of this L. Mean this equation should be that we are including aqueous with lithium hydroxide. Water is not a reactant in this reaction. Only lithium hydroxide is the reactant. Okay, now to solve it, first of all, we have to balance this equation. Okay, so the balance of this will be 2 lithium, 2 water, 2 lithium, 2 hydroxyl ion. That's only then it will form H2. Okay, so here 2 lithium and 2 hydroxyl ions are being formed, so it will be 2. 2 lithium hydroxides are needed over here. Okay. And so all these are the elements. So according to the Hess's law, I'll be going from here to here this way. So this is your X value. Now this plus this will be equal to this plus this. Lithium hydroxide is dissolving in water, making minus 21. So it is here minus 21 kilojoules. So minus 485 and minus 21, both will be included. Now let's see. This is here X plus minus 286 is equal to minus 485 plus minus 21. Is this okay? It's not okay. Why it's not okay? Because you can see minus 286 is the enthalpy change of the formation of 1 mole of water. But here we need 2 mole of water. So you will have to multiply it with 2. Similarly, this is the standard enthalpy change of the formation of 1 mole of lithium hydroxide. But here we are using 2 moles of lithium hydroxide. So we will multiply this with 2 also. Okay. So this is the standard enthalpy change of the solution of 1 mole of lithium hydroxide in excess of water, that is minus 21. So as 2 moles of lithium hydroxides are being dissolved, so it will be multiplied by 2. Now this is very simple mathematics. This is X plus minus 6 2s are 12, 1, 8 2s are 16 plus 1 17, 1 2 2s are 4 plus 1 5, minus 572 is equal to 5 2s are 10, 0 1, 8 2s are 16 plus 1 17, 1 and 4 2s are 8 plus 1 9, minus 970. That is plus 21 into 2 minus 42. Now let's see, this will be X minus 572, that is equal to minus 970 minus 42. It will be like this, brackets are removed. So X is equal to minus 970 minus 442 plus 572. Okay, so when you will calculate it, X is equal to 440. But you know that the standard enthalpy change of reaction of lithium with water is minus 222. This is kilojoule per mole. This is the standard enthalpy change of this reaction. That is minus 222. But it is 440. So you can see this is for 1 mole. Over here we are having 2 moles. So our value will be X is basically minus 220. This is the value we are calculating over here, minus 220, and this is very near to minus 222. This is the theoretical value, this is practical value. Practical value is always little bit less because we cannot exactly measure all the amount of heat released during such experiments. Okay, so this is the standard enthalpy change of the reaction of lithium with water. This is for 1 mole, but we have calculated here for 2 moles, that is minus 440 kilojoule per mole. So the answer for X is minus 440 kilojoule per mole. This is the answer for X. I hope this is understood to you that why are we not including water in this reaction. The only trick in whole of this question is not including water, standard enthalpy change of the formation of water in this part. You know that in most of the questions, this is single arrow, this is single arrow, and this is single arrow. But here, the trick is that we are using 2 arrow. Lithium, hydrogen and oxygen, they are used to form lithium hydroxide, which is then dissolved in water to form aqueous lithium ions and aqueous hydroxyl ions. Hope this is understood to you and you have really enjoyed it. Thank you for watching.